Happy Monday. Welcome back. Today we're going to talk about what are called compound events, and that is when two or more events are put together to make one single event. And you're always going to see the word "or" in these particular problems. All right, now there's two different kinds, the easy and the hard. The easy ones are called disjoint events, and that's when the events cannot happen at the same time. All right? So, for example, let's say I want to get a new dog, and I either want to get a pit bull or a Rottweiler. There's lots of other kinds of dogs out there, but I want to get a pit bull or a Rottweiler, but I can't get one that's both of them at the same time if I want a purebred dog. All right? So they don't overlap. All right? So what I would do is I'd find the probability of A or B getting a pit bull or a Rottweiler, and I'd have to find the probability of A, meaning how many pit bulls are out there for sale compared to all the other dogs, and probability of B, how many Rottweilers are out there for sale compared to all the other dogs, and add their two probabilities together for my chances of actually finding one of those dogs for sale in the area. All right. Now the other option is what are called overlapping events. That's when events can happen at the same time, meaning again, you're one event that's actually happening, you got two choices. Like you want to buy a new car, and you either want a Ford F-150 truck, or you want any black car. You don't really care. If you can't get your F-150, you'll just take any car as long as it's black. You want a black one. So again, there's some overlap because there are some Ford F-150s that are black. All right? So again, there is an overlap in between. So this one's a little more challenging. So again, if you're finding the probability of A or B, you'd have to find the probability that A happens, find the probability that you can find a Ford F-150 in your area for sale. All right, plus the probability of B, that'd be the probability of finding a black car for sale in your area. But some of them you've counted twice. If there was a black Ford F-150, you just counted it in both groups. So you got to go back and subtract out all of the ones that are in both groups. So you have to know how many are in that mixed group. All right, because you have to subtract that probability out. So again, that's a little bit more work, a little bit more thought. So let's do an example of each kind. All right. First off, the simpler one. You roll a single die, numbers 1 through 6. What is the probability that you roll a 5 or a 6? All right, so we're going to find the probability of getting a 5 or a 6. What we're going to first off do is find the probability of getting a 5, and then add to it the probability of getting a 6. But I can't be a 5 and a 6 at the same time. There are no rolls that have both numbers on the same side. So this would be one of those, again, you went back, a disjoint event. You cannot be a 5 and a 6 at the same time, so I don't have to minus out anything because there is no overlap. So the probability of there being a 5, well, there's 1 out of the 6 faces on a die is a 5. And a 6, same thing. 1 out of the 6 faces on the die is a 6. Now you got two options here. Option 1 is that you could add them as they are and get 2 6. Divide that out and you have your final answer, 0.3 repeating. Option 2 is you could have turned each one of those into a decimal first, 0.16 repeating plus 0.16 repeating, and then added them together, and you would have ended up with 0.3 repeating or 0.32, which would have, again, been basically the same thing. All right? So hopefully that makes sense. That's a little bit of an easier one. Well, harder ones is when we get some overlap. And I know some of you don't know your cards very well, so if you don't play cards, I'll help you on this one. I don't think I put any card questions that were hard on today's page. So I'll do the card question with you. So a card is randomly selected from a full deck of 52 cards. What is the probability that that card is a face card or a red card? All right, so first off, let's find the probability of A. Probability that this is a face card. All right, so that's our first thing. Then we're going to find probability of B. In this case, the B is the card being red. Terrible writing, but red. And then, is there any overlap? Are there any face cards that are red? Well, yes. There's the King of Diamonds and the Queen of Diamonds and the Jack of Diamonds and the King of Hearts and the Queen of Hearts and the Jack of Hearts. So we'll have to subtract out that overlap, the ones that fit both groups. So let's go for the face cards. Again, you have to know how cards work. That's why I'm not trying not to give you any of these on tests or anything like that, because I know some of you don't know cards well. But trying to get a face card. So there's 52 cards in the deck. And like I said, there are kings, queens, and jacks. Those are face cards. And there are 4 of each. So there are 12 total face cards. Right? Now I'm going to add to that the probability that a card is red. Well, half the cards in the deck are red and half are black, so there's 26 red. And then I need to minus out the probability that something is both. I need to minus out all of the red face cards. So that was the King of Diamonds, Queen of Diamonds, Jack of Diamonds, King of Hearts, Queen of Hearts, Jack of Hearts. That's 6 of them. All right, now once again, I have the option of keeping them in fraction form, which might be a good choice since they all have a common denominator. I can just do 12 plus 26, which is 38, minus 6, which is 32. And that makes my calculator work a lot easier. I don't have to do as much stuff. I can end up with 0.615, or 0.61, or 0.62. Well, at least 2 decimals, though. 2 decimals is always the key. There's no reason to have less unless there's zeros. All right, now again, or you could have gone back and you could have done each fraction individually. You could have done 12 divided by 56 and got 0.214, and done 26 divided by 52, which is 0.5, and then minused out 6 divided by 52, which is 0.115, and you could have done it that way. 0.214 plus 0.5 minus 0.115 ends you up with 0.599. Again, because I did so much rounding, so it's more accurate to leave them in fractions and divide at the end. That would be my suggestion. Instead of keep doing all of this extra work, a lot of times it's going to be easier, but it's different if you have different denominators. But since today's are all actually single events, but you're looking for multiple things, you will have matching denominators. There is no replacement because there is no second event. We're not drawing 2 cards, we're just drawing 1 card. But it could be 2 different possible results. So again, that's what's different between today and what we did on Friday. All right, I hope this makes enough sense for you to get it done. But if anything seems confusing or weird, and some of you figured out I've done a crappy job of creating some assignments this week. Again, I've been in a bit of a mental haze as I've been fighting off this cold. Again, luckily not COVID, but it's still a cold, and the brain's not always all the way there. So I apologize for that. But again, if you have any concerns, issues, a question doesn't seem right, just get on the Zoom and ask. I'll help you out. All right, good luck today.